Sitting in lecture with the plate of grilled bacon. Home my girl eats and his back house is shaking.
Yo, work in our town is dope and pretty.
So check out how we live in the electric city. We call Gville
What?
the electric city. Gville.
What?
The electric city. The electric city. Local coal power plant GRU
Supplies energy for me and you. Generating power for the entire town.
We gotta make sure to keep the emissions down.
Wanna go overboard on Christmas? Let's know. Probably got 450 megawatts of
Lignite. Harmful flue gases are produced.
containing SOx, NOx, and fly ash to be reduced. Particulates are captured by ESP.
Corona power influencing efficiency. NOx plus ammonia plus oxygen
Yields water and some harmless nitrogen. Coal power exists, but don't lose your head.
Controls are in place to protect you from lead.
Lead, lead, lead.
This presentation is about the emissions associated with coal-burning power plants such as Gainesville Regional Utilities. By the end of this presentation, you should have learned how the emissions affect the public health, how it affects the environment, what technologies are used to control the emissions, and what sorts of regulations are in place to protect people and the environment. The process of burning coal begins in the crusher house. Appropriately named, the crusher house crushes the coal until it is small enough to enter the pulverizer. The pulverizer further grinds the coal into a fine powder. As a fine powder, the coal is ready to enter the boiler. In the case of Gainesville Regional Utilities, the boiler was designed to burn the coal at a temperature of 2400 degrees Fahrenheit to generate 1.7 million pounds of steam per hour. This steam heats steel pipes filled with water, producing approximately 2,000 pounds of pressurized steam, which is applied to a turbine. The spinning turbine delivers 315,000 horsepower to an attached generator, providing the plant with 248 megawatts of power. The problem with this process lies within the coal content and applied heat. Coal consists primarily of carbon, hydrogen, nitrogen, oxygen, and sulfur. When heated, the elements are capable of reacting with one another, and as a result, pollutants such as nitrogen oxides, sulfur dioxide, and carbon monoxide are formed.
When electricity is generated in coal-fired power plants, harmful fumes called flue gas are produced. These fumes contain toxic pollutants that could be emitted into the environment if not properly controlled. Regulations are put in place to ensure proper air control technologies are implemented and industries are able to provide power to the public without jeopardizing their health. Last amended in 1990, the Clean Air Act required the Environmental Protection Agency to set national ambient air quality standards for pollutants considered harmful to the public and the environment. The pollutants listed under these standards are considered criteria air pollutants and are strictly regulated. On December 16, 2011, the EPA finalized the first national standards to reduce mercury and other toxic air pollution from coal and oil-fired power plants. However, it was not long until industry challenged the standards put forth by the EPA, requiring additional cost-benefit analysis the following year. This exchange went on for a while until the EPA was able to finalize the supplemental findings in 2016, ensuring the enormous health benefits of the mercury and air toxic standards. With the standards put in place by the EPA, we can control the emissions of harmful pollutants from coal-fired power plants. Pollutants created by combustion of coal include nitrogen oxides, sulfur dioxide, lead, particulate matter, mercury, and carbon monoxide. For nitrogen oxides, nitrogen dioxide is regulated by the emission standards put forth by the National Ambient Air Quality Standards. The primary standards put forth are to provide protection to the public health, while the secondary standards listed are to provide protection to the public welfare, animals, crops, and vegetation. The primary standard for nitrogen dioxide is 100 ppb. This is in the form of the 98th percentile of 1 hour daily maximum concentrations over 3 years. The primary standard for sulfur dioxide over 1 hour is 75 ppb in the form of the 99th percentile of 1 hour daily maximum concentration, also averaged over 3 years. On the other hand, the secondary standard for sulfur dioxide over 3 hours is 0.5 ppm and is to not be exceeded more than once per year. The primary and secondary standards for lead are the same at 0.15 micrograms per cubic meter. This is on a rolling 3-month average basis. For particulate matter, PM 2.5 and PM 10 is regulated and both contain primary and secondary standards of 12 micrograms per cubic meters and 150 micrograms per cubic meter, respectively. These are under the designated time intervals. Emissions of mercury are regulated under the Mercury and Air Toxic Standards, also known as MATS. These standards establish an effluent limitation of 0.356 ppb on a monthly average and 0.788 ppm as a daily maximum. Last but not least, the primary standard for carbon monoxide over 8 hours is 9 ppm, while over 1 hour the standard is 35 ppm and is to not be exceeded.
A major concern of coal burning is the impact of particulate matter, classified as PM 2.5 or PM 10. Both contribute to respiratory problems. However, PM 2.5 travels deeper into the airways than PM 10 and is therefore a greater concern. PM 2.5 has been linked to causes of asthma, lung infections, and with long exposure has been linked to more severe illnesses such as chronic obstructive pulmonary disease or even lung cancer. Sulfur dioxide can also affect the respiratory system, posing greater risk to children, the elderly, and to individuals with pre-existing respiratory problems. For adults and children who are susceptible, inhalation of sulfur dioxide causes inflammation, bronchitis, and decreases in lung function. Further threatening the health of those susceptible, nitrogen oxides react with chemicals in the atmosphere to create pollution products such as ozone, nitrous oxide, and nitrogen dioxide, which can increase wheezing and coughing in asthmatic children. At high concentrations, it may cause inflammation as well. Aside from causing respiratory problems, particulate matter can travel from the lung to the heart, making it a probable cause of cardiovascular diseases and in worst-case scenarios may lead to death. Other problems that could arise from the emissions include abnormalities in fetus development. When mercury, a heavy metal contained in coal, is released into the atmosphere, it becomes deposited in water, converted into methylmercury, and can travel up the food chain, negatively impacting the children of pregnant women. It has been linked to neurological disorders in these children, in addition to premature birth. While these emissions pose a threat to the public health, threats to the environment are also extremely important to address. Global climate change is caused by the accumulation of greenhouse gases in the Earth's atmosphere. Two of the major greenhouse gases contributing to climate change are products of coal combustion: carbon dioxide and nitrous oxide. As the concentrations of these gases in the atmosphere increase, the average global temperature gradually increases, resulting in the melting of polar ice caps, the thawing of permafrost, the rising of sea level, floods, extreme weather, and so forth. The change of climate creates many alterations in ecosystems, causing a decrease in keystone species such as coral reefs.
Hi guys, so now we're going to talk about the control technologies associated with each of these pollutants. So first up, we got sulfur dioxide, and sulfur dioxide is usually controlled either by blending the fuel, using fuel with a lower sulfur content, or just straight up removing it from the flue gas. There are two methods to remove it from the flue gas, which include wet FGD systems and dry FGD systems. And dry FGG systems are often preferred because they have lower construction costs, simple unit operations, result in reduced water consumption, and are easily handled. And the byproduct is easily handled because it's solid. Within these dry FGD systems, there are dry scrubbers at CDS, circulating dry scrubbers, dry sorbent injection, DSI, and spray dryer adsorber. Nitrogen oxides are controlled via selective catalytic reduction, SCR, or non-catalytic reduction, SNCR. For these processes, a chemical reagent is injected into the flue gas, reducing NOx to N2 and H2O. SNCR injects either urea or NH3 at high temperatures being 760 degrees Celsius to 1100 degrees Celsius. However, at these high temperatures, excess reagent may react with oxygen to form NOx, reducing removal rates. So this actually reduces the removal rates to around 15 to 35%. Because of these low removal rates, SCR is the preferred method and is the method used in the Deerhaven plant. The SCR method uses a catalyst which allows it to perform at lower temperatures, 360 to 450 degrees Celsius, which makes the process overall energy cheaper. But you do have to buy the catalyst, which makes it slightly more expensive. But it does result in 90% of NOx emissions. It does result in 90% removal of NOx emissions. So it is the favored method. Next up, we have carbon dioxide, or CO2. The amount of CO2 released is largely dependent on the coal you use. So if you use a coal that has lower carbon content, such as anthracite and burns cleaner, then you'll get lower CO2 emissions. But if you use a coal like lignite that has a higher carbon concentration and hasn't been in the soil as long, then you will get more CO2. Next up, we have mercury, which is captured with powdered activated carbon, or PAC. This powdered activated carbon is usually modified with a halogen, such as chlorine or bromine. Modifying it with chlorine in high concentrations has shown up to 90% of mercury removal, and even in low concentrations has shown up to 60% removal. Researchers think that this removal could be enhanced up to 10 to 15% if the chlorine was substituted with bromine. Finally, we have particulate matter, which can be classified into PM 2.5 or PM 10, which is just based on the size of the particle. Particulate matter control devices include electrostatic precipitators, ESP, fabric filters, FF, mechanical collectors, MC, and Venturi scrubbers, VS. The chosen technology of the Deerhaven plant included a giant Venturi scrubber to collect their particulates. Some pros and cons of each method. So the ESP captures PM results in a high capture efficiency. It does not use a reagent. It's typically used for solid fuels, but it does also have a high capital cost. It does have some co-benefits of it where it captures.
As a brief summary, sulfur dioxide, nitrogen oxide, carbon dioxide, mercury, lead, and other pollutants are products of burning coal. If these pollutants are not controlled, then it could be detrimental to the public's health or even the environment. Some impacts include problems to the respiratory, cardiovascular, and nervous system, as well as contribution to climate change. Luckily, there are regulations in place that require these power plants to meet specific emission standards, and there also exist control technologies to help meet these standards.